Okay, everyone. Our last speaker before we go into our lightning talks is Christian Posta. If you don't know the name, you may know some of the books he's written. Istio in Action. Have we not talked about Istio enough here? You're going to hear all about it again and how it fits in microservices. Have you not read that book, Microservices for Java? Christian Posta is the author for both of those books. Christian is the global field CTO for Solo.io. Christian has worked as numerous capacity as an entrepreneur, as a technical director, as an influencer, a microservices SME, and just an all-around great person that I've worked with for 7 years. So I'm proud to introduce Christian. Give him a hand of applause.
Thank you, Michelle. Thank you all. All right, let's get going. We have a lot to cover, and I heard they're going to open the bar for the lightning talks, so I'm standing between you and alcohol, and myself and alcohol. So let's get going. So, like Michelle mentioned, my name is Christian. I work for a startup called Solo.io. We focus on building tooling to help you adopt service mesh easier and solve some of the problems around going to microservices and containers. And I am in the middle of writing a book called Istio in Action. I've been involved in the Istio community for about the last couple years. And I've contributed to Istio and some of the open source projects around it and open source projects in the past. So we're going to move quickly through the problem statement. You're going to microservices, you're taking your monolith and strangling them or breaking parts out of them, and you're going to the system that becomes more complicated. You're adopting things like containers, things like Kubernetes, and possibly service mesh, and things are complex. Kubernetes is great at helping you deploy your applications, helping to start them, stop them, manage them across multiple nodes. But once they're deployed, they need to talk with each other. They need to communicate with each other. Services are communicating with each other, with databases, with queues, with caches, with whatever. Now, in this environment that's now fairly complex, got a lot of moving parts, containers, things are talking to each other over the network in more, higher numbers than before. We need to go, we're taking on this complexity and we're doing it for one reason, it's to go faster. So you may have heard this before, we're trying to go faster. The surveys from the State of the DevOps report show that in recent years, through the proxy metrics that they capture about high-performing teams and the window between high-performing teams and low-performing teams, for being able to deploy faster, number of deployments, or how quickly they're able to get a change out into production. That window between high-performing teams and low-performing teams is actually shrinking. You can see here, this is the 2017 report, but the trends are similar. More recent reports that deployment frequency, you can see that window is shrinking. Lead time for changes, that window is shrinking. So we're able to go, we're automating, we're using containers, we're using Kubernetes, we're able to get things out, CI/CD. But the problem is, it doesn't help us just to deploy things fast. Right? We have to do that in a safe way. We don't want to make changes to the system that negatively impact the system. Those last two proxy metrics, mean time to recovery and change failure rate, those are growing. So although we're going faster, we're putting crap into production, or at least destabilizing our systems, and making it harder to figure out when things go wrong, how to remedy that, how to fix that. So that's the lens through which we're going to look at the rest of this presentation, and through the lens which Solo.io, the company that I work for, that we're looking at this problem. How do we make changes to the system fast, but do that safely, and minimize blast radius when making those changes? So I'll cover service mesh real quick, just by show of hands. How many people know what a service mesh is? You know what service mesh technology is? Okay, that's most of the room. That's good because we had Lynn give a wonderful presentation on Istio earlier today, and it's been brought up in a few other conversations. So real quick, a service mesh is decentralized application infrastructure, so it runs at the application layer, that solves for problems that crop up when you go to a services-style architecture, when you have lots of services communicating over the network. How do you do security? How do you assign identity to these services? How do you enforce policy about which services are allowed to interact with which other services? How do you do resiliency, so like timeouts, retries, circuit breakers, consistently across all the services? How do you do routing control to be able to finely tune what requests go to which versions of our service? And finally, and most importantly, how do we get an understanding, a baseline, consistent understanding about what's happening on the network between the applications? How many requests are flowing? What's the latency of these requests? How many 503s? How many retries, circuit breakers? How do we get a consistent baseline of these top-line metrics when services start talking with each other? Because if we can't understand what the steady state is, how are we going to know when things go badly? And when things do go badly, how are we going to know how to, or where to look and how to fix that? So Service Mesh does this, or implements this, by putting little proxies next to each one of the service instances. So think you have a JVM, you have a proxy next to it. You have a Node.js process, you have a proxy next to it. And those get co-deployed atomically. Thankfully, Kubernetes makes this deployment pattern, a sidecar deployment pattern, a lot easier. And then you have a set of components that is charged with managing the proxies, configuring the proxies, and that's known as the control plane. At a high level, what the service mesh provides are things like client-side load balancing, service discovery, timeouts, retries, circuit breaking, TLS, mutual TLS between the applications. Since the proxy is on both sides of the connection in this mesh, we can issue certificates and do mutual TLS. We can do policy enforcement, traffic control, and we can drive all of this behavior in our network through an API. The service mesh basically gives this programmable API on top of our network. So not only can we observe what's happening, we can also control it and make changes, divert the traffic, or institute different retry policies for different layers of our application, and so on. And so I talked about Kubernetes being kind of the platform into which you deploy your services. Then they need to talk with each other. They have to solve these new challenges. That's where Service Mesh comes into play. But as I pointed out earlier, as we try to move faster, our goal is to move faster safely. We want to reduce the mean time to recovery, and we want to reduce the impact of changes in production. To do that, Service Mesh by itself doesn't actually solve those problems. Service Mesh provides the API to help with solving those problems, but ultimately what you end up doing is building these engines on top of, to complete your platform. Things that will drive a canary release, for example. Something that will look at how to shift traffic, let's say 1% of traffic to our new application or new version, and then watch the metrics and make sure that latency and throughput isn't negatively impacted with our new release, right? And then make a decision. Okay, if everything looks good, let's roll up to 5%, let's say, or 10%. Or if things start to look badly, they go outside of these boundaries, let's start to roll it back. But you don't want someone sitting there manually clicking and observing and watching the logs. You want to automate as much of this as possible. So what you end up doing is you build this engine that sits on top of the service mesh and drives its API, watches some of the observability and telemetry that you're getting back, and automates these processes. Now, this example of building on top of the mesh, that you can build the same things for doing chaos engineering, chaos experimentations. Define the parameters of an experiment, run it until it goes outside those boundaries, or allow it to continue and verify your system. Or debugging, or A/B testing engines, or traffic analysis, or forensic. All these things now become enabled by the service mesh with the goal of making changes to the system and doing that quickly and doing that safely. So let's step back for a second. So this sounds so great, but it doesn't come without its own trade-offs, right? All of these cloud systems are complex. Do you need a service mesh? Let's look at that real quick. These are some of the challenges that you have to solve when you go to a cloud platform, whether that's Kubernetes or VMs on a public cloud. When you have elastic scalable infrastructure like this driven by APIs, you need to solve for, and you deploy applications and services onto them, you need to solve for these problems. I'll continue. Routing, back pressure, health checking, request shadowing, surgical routing, A/B rollouts, telemetry collection, distributed tracing. So these are things that the service mesh does. But that's not the only way to solve them. Netflix actually showed how you can do this by using application libraries. Various libraries like Hystrix and Ribbon and Eureka and Zool and all these ones that help build the foundational pieces to be able to move fast safely. Right? So that's the goal. Now, if you're in an organization that uses Java and you're standardizing on Java, that's awesome. You maybe build this infrastructure, use it from Netflix. Keep the complexity as low as you possibly can for as long as you possibly can. But maybe you say, we want to use Java, but we want to use Node.js too. At the edge, maybe. Maybe Go. Golang is a hot new programming language everybody wants to use. Python is awesome. How many people are doing Python? Awesome. Python's great. There are still systems, legacy systems, for languages that you might not think of, that still you have to solve these problems, especially if you're going to try to port them into a cloud platform. So, like I said, adopt the complexity when you need it. Service Mesh solves for how do you operate this across multiple languages, across multiple frameworks of a single language, and do that with some level of consistency. Instead of trying to manage all the different permutations of libraries and frameworks that you might have to cobble together and hope that they're implemented exactly the same way. If you leverage Service Mesh, you're able to operate your services with less toil than you would if you expanded this out to multiple languages and platforms. Now, I've been thinking about this a little bit. It doesn't matter where the Service Mesh is implemented, whether that's explicitly as a service mesh, or if it's implicit, or in your language of choice. However you get there, you need to solve for these network communication challenges. So which one to choose? Istio has probably gotten a lot of airtime. It's been around for a while. It's becoming more mature. People are starting to adopt it. People are looking at it and planning around it. But there are more options than just Istio. So, for example, Linkerd. How many people have heard of Linkerd, just by show of hands real quick? Okay. Linkerd has probably been, the startup around Linkerd, Buoyant, kind of helped coin the term service mesh. They started off their efforts with Linkerd with a JVM or Scala-based service mesh, which had some of its challenges. They've recently pivoted and changed to a Golang and Rust-based implementation where the proxy is written in Rust. And they're focusing on something very important for this type of infrastructure. They're focusing on ease of use. They're focusing on minimal configuration and minimal impact to adopting in terms of performance and so on. And so their latest release, 2.3, and they're going to announce 2.4 pretty soon, within the next week or so, will continue to add more features. So they've sacrificed features, especially compared to Istio, for these goals, to be easy to use, minimal config, and highly performant. But they're starting to add more features, and we'll see it continue to grow. Another one from HashiCorp called Consul. You might recognize Consul as a key value store used primarily for service discovery in these dynamic environments. Consul is building a service mesh called Consul Connect around this service discovery mechanism. And they started off by building policy enforcement and mutual TLS. So of all the capabilities of a service mesh, they started off with that one. And they're focusing more on the non-Kubernetes deployments, so VMs and where you might have Consul running already, and then helping people move to Kubernetes. Right, so Istio kind of started the other way, and Linkerd started the other way. They're going from Kubernetes-focused workloads and extending out eventually to VMs. Consul is going the other way. Consul is in some way similar to Istio in that it uses Envoy proxy as its sidecar proxy in the service mesh. So we talked about Istio. Lynn did a presentation on Istio. I'm writing a book on Istio. Go buy it. So I'm not going to dive into that. The last one I want to talk about is Amazon App Mesh. So App Mesh is another service mesh, this one offered by AWS, and is free on AWS. So if you're going to AWS, it makes a lot of sense to use App Mesh. The control plane for App Mesh is managed, so you don't even have to deal with that. All you have to do is figure out how to get the proxies loaded next to your instances, which they have help for that. And you can run it on Kubernetes, you can run it on EC2, you can run it on ECS, on Fargate, on multiple different platforms. So like I said, Service Mesh provides this API on which you can build tooling to help you. Here's the diagram I used earlier. To build safety tools on top of your cloud platform. And that's a very interesting concept and something that at Solo we've been talking about since about October last year, 2018. So we announced this open source project called Superglue. And Superglue is intending to first help simplify how you install and operate a service mesh in a real environment. And what I mean by real environment is you're going to bring your own Prometheus, you're going to bring your own root CA, you're going to have potentially multiple clusters. This gets really complicated. So we want to simplify how you install and operate a service mesh. And we don't care which one you choose. Istio, Linkerd, App Mesh, Consul. Kong is going to announce one soon. Nginx is going to announce one soon. There's going to be multiple different implementations of service mesh. This space is far from being won by any one particular vendor. So there's going to be multiple vendors for a little while. But what we want to do is make it easier to manage, regardless of which one you use. Provide a simplified API on top of the mesh. So you're not locked into any one specific vendor, especially while all of this stuff is pretty tumultuous in the industry right now. And then provide that specifically for the reason of building those capabilities on top of the mesh. When you start building canary engines or chaos engines or debugging engines on top of mesh, you need to build that against the service mesh API. So the idea we had was let's simplify the API and extend it across multiple service meshes. Now this happened to be validated recently by Microsoft and some of our other partners that we launched this with, called the Service Mesh Interface. Anybody heard of the Service Mesh Interface? Just curious. At KubeCon it was announced, a handful. And so this is basically what we were starting to do with Superglue. We define a spec of features that we expect that you would see in a service mesh, and it would apply to any of the service mesh implementations. Focusing on, initially at least, on traffic routing, traffic control, for being able to do things like canaries, traffic metrics, so what the APIs and for telemetry might look like, and then traffic policy, describing what services are allowed to talk with which other ones. Now, this is a new spec. It's continuing to grow. Help from the community, help from the users, help from the vendors is appreciated. But its main advantages right now are to help you with your service mesh exploration journey. Which service mesh do you start using? If you start using, let's say, Linkerd, you use it against SMI so that you can understand the interface, understand the capabilities of the mesh, and then you can also explore Istio and use the same interface and understand exactly the same capabilities of the mesh without having to go all in on one right now. Because like I said, there's no clear winner in this ecosystem right now. If you do end up adopting, let's say, Istio on premises, and then maybe later at some point you go to AWS and you realize, all right, well, AWS offers all this stuff, I'm going to use App Mesh also. You need some way to federate both on-premises Istio and in-cloud App Mesh, or what other various implementations you might choose. And lastly, for vendors like us, like Solo, we want this standard because then we can build things on top of it. Then we can build higher value functionality, and you can build higher value functionality on top of the mesh without being locked into one specific one. So getting started with service mesh, I would say that for large enough deployments, heterogeneous deployments, service mesh is the right architecture. So adopt it incrementally, start at the edge, solve problems like maybe security or traffic routing or resilience. Pick one. Don't try to do all of them at the same time. I've seen the organizations that we've worked with that are successful. They've identified one pain point that the service mesh can help with and slowly and incrementally build into their adoption of it. Now, we're working on, like I said, tooling to help make service mesh adoption easier and help make the possibility of writing extensions on top of service mesh. And I'm going to show you a demo here. I think I have a little bit of time here. The projects that we're working on are loosely these ones that I'll show here. So one called Squash, which is a multi-language distributed debugger. And when you have a service mesh in place, actually Squash is service mesh agnostic, so you can use it outside of a service mesh. With your applications running in a cloud, you can connect up to multiple instances, multiple applications, potentially written in multiple languages, and get step-by-step debugging through your IDE. Something called Loop, which is in a service mesh environment, as requests are flowing through the system, if you encounter errors, you can capture the requests and save them off and replay them in a different environment, and attach the debugger to it so that you can step-by-step debug through the requests that are being replayed. Glue Shot is a chaos engineering framework for being able to specify experiments, specify things like fault injection for things like delays or request loss or 500s or whatever, and watch how the system behaves and verify that it's supposed to behave the way you're expecting. Lastly, I'll share these slides. You can look through these. Is Glue, which is an API gateway built on top of Envoy that is very complementary to service mesh. A lot of service mesh implementations don't have an API gateway. And so things like console, things like Linkerd, app mesh, and so on, Glue plugs in, and Istio plugs in really nicely. So I'm going to leave you with these additional resources. Let me show you a demo real quick. I have a couple minutes, right, Jim?
Yes.
Yeah.
Go ahead.
Okay. So the first thing that we're going to look at is,
Can you make your screen bigger?
yeah, yeah. Is that better?
Anybody in the back? Yeah? Yes. Yeah.
Awesome. All right. So the first thing we're going to look at is we have an installation of Istio going here. All right. So we've installed it through some other means. What we want to do is take control of it and manage it, potentially explore other service meshes, potentially augment it with extensions on top of it, and we're going to take a look at how to do that. So the first thing we're going to do is, so we have Istio installed, and we also have the Istio Book Info demo app installed. So this is the architecture of the demo app. Call into a product page, shows you details about a product, including reviews and ratings and so on. This is what it looks like. So if I refresh, you should be able to see it. It's working. So first we're going to do is we're going to go to servicemeshhub.io. And the Service Mesh Hub is this management piece. It's this ability to understand a mesh, install a mesh, upgrade it, and extend it out to multiple clusters. Eventually, that part's not there yet, but it's pretty close. As well as add extensions. So if we look at our extensions list, we're trying to build like a catalog of extensions that you can add on top of a service mesh. Things like, for example, if I zoom in, things like Flagger, which is from Weaveworks as a canary analysis engine. Things like you can add Glue as an extension, API gateway to multiple meshes. Things like Glue Shot, chaos engineering. Kiali actually Red Hat wrote Kiali as an observability tool for service mesh and so on. So this is running on servicemeshhub.io, which is a read-only cluster. What we're going to do here is we're going to install it locally. So we click on install, and we're just going to copy this and install that into our cluster that we have here. So we'll give that a second to install and to come up. The next thing it told us to do is to port forward so that we can look at the hub running locally. So let's do the port forward. Now, if we go to localhost 8080, we can see the local version of the Service Mesh Hub. We can see it automatically discovered Istio. If we didn't have Istio installed there, we could install it using the hub here. But you can see it automatically discovered, understands exactly what capabilities the Service Mesh has. If we look at it in more detail, we can install extensions, install new capabilities on top of Istio. In this case, we're going to install an SMI adapter. SMI is that Service Mesh interface that we can now use this vendor-agnostic interface for driving Istio. Let's install it into Istio. Oops, is that right? There we go. The SMI is here. We're going to install it. We'll put it into the Istio system, say install extension, and cross fingers, a live demo. OK, that installed. Now if we come back to meshes, so now we have Istio. We can see it has an extension installed. Let's say we want to install a new mesh. Let's come over here. Maybe it's Linkerd we want to install. My Linkerd. Link. Put it in the Linkerd namespace. And say install mesh. And we should start to see it spin up. So the Service Mesh Hub is here is helping you do all that stuff. If we wanted to add extensions to this mesh, we could do that as well. And now Istio is configured to be able to talk the SMI, the Service Mesh interface. And I have a demo for that, but I don't know how we are on time. Okay, all right. Time for questions?
Actually, hey, that's on. All right, I understand Christian has never missed a free bar in his life. And even one where he's had to pay, so he will certainly be upstairs at 4 o'clock,
That's right.
I'm sure, for an hour or 2 or 3 or 4. You're not leaving tonight, are you?
As long as the bar's open.
Yeah, as long as the bar's open. So there we go. With that, I'm going to pass it over to Adam, and then we'll. Yeah.
Thanks.